Ma'am, can you show the formation of hexanol?
Okay. Um, but I can't. Yeah, I can see you now. I wasn't able to see it. So hex is how much?
6.
Hex is when you have 6 carbons in your chain, right? So you will
Yes.
make 6 carbons. 1, 2, 3, 4, 5, 6, and just add OH. Okay. And like satisfy the valency, it's already bonded on 2 sides. So 2 hydrogens it will have H2. It like all the carbons in the middle, if they're not bonded to anything else, they will have their valency as H2 because they are bonded on both the sides. So their valency will be H2, and the outermost will be H3. Okay, clear?
Yes, ma'am.
All right. Now let's move on to the nomenclature. Before moving on to the nomenclature, I have to like mention also we did functional groups, right? So in this functional group, let me write this one thing. What is this? Can you tell me what is this?
Methane.
Methane, right? So this is methane. And if I take one hydrogen, so CH3, if I CH4, if I remove one hydrogen, minus one hydrogen, I will get CH3, right? So
Yes.
this is called methyl. methyl, methyl. Okay.
Yes.
Now, when I have C2H6, what is this?
This is methane.
C2H6, C2 and 1, 2, 3, 4, 5, 6.
En.
Sorry, can you repeat?
Ma'am, Ene. Ethane.
Ethane, ethane. 2 carbons. We have 2 carbons, right? Are you saying ethane or ethene?
Ma'am, Ene. Ethane.
ANE or
Ene.
ENE?
Ene.
ENE. ENE, ethene would be when you have double bond between these 2 carbons, but there's no double bond, right? Just
Oh,
C2 and H6. Like draw 2 carbons and satisfy the valence and make 6 hydrogens. So there is no space for double bond.
ethane.
So ethane. Yeah. So if this is ethane, if I remove one carbon, sorry, not carbon, this is ethane. I'm removing one hydrogen. So this is C2H5. So this will be ethyl. Okay, clear?
Okay.
So all the car like the whole carbon chain, um this root names we had methane, ethane. So if you remove one hydrogen from each of them, so methane will become methyl. So YL will be added at their end. So ethane will become ethyl, butyl, propyl. Okay, so that's how it will keep on changing. So this ethyl will also be used as a functional group, you can say. Okay, now let's go into a little details about that, the nomenclature, and like why are we studying so many functional groups? What is the use of this suffix, this prefix, and all of that? So we will start with nomenclature. So write down the heading nomenclature. So give me 1 second. All right, shall we start, Fatma?
Yes, ma'am.
Okay. So we'll keep it very like you don't have to write anything. Okay, like I said in the last class, I mentioned it that I'll share the PDF after the class, or like this, whatever I'm writing on the screen, you'll get it after the class. But just whenever I ask you to solve a question, solve that in your notebook and tell me the answer. Will go like a little faster than usual, and you don't have to write it. But after the class, revise everything, write down the notes, and I'll check it in the next class. Okay, because
Okay.
we are short on time, that's why we are using like going like this. Okay, so nomenclature is basically when you have a compound more like hydrocarbon, and you are naming that, right? You'll mention everything about that. Like a functional group is present on that carbon chain, you have to mention that also. So basically naming a whole compound. Okay, now till now what you were doing when you had 1, 2, 3 and 4 carbons in a chain. So what you were doing is you were counting the number of carbons 1, 2, 3 and 4, and you were saying that okay, the root name is bute, so it, and there is no double bond, so I'll write it as butane, right? That's what you were doing till now. So we'll nomenclature, this is nomenclature only. So you've been doing nomenclature before you even knew you were doing nomenclature. Okay, but now we'll add the functional groups also. We'll add we'll add some functional groups and then we'll continue. Okay, now we have got a few rules for nomenclature. The first rule is prefer or choose the longest chain. Wait, let me, yeah. So we will choose the longest chain. Now, what is that supposed to mean, right? Longest chain means if I have this is my carbon chain, and in this I have somewhere the carbon is attached here also. Now this is something new that you haven't observed, right? So we will start in such a way, like we'll start the counting the number of carbons. Okay, and we have to find the maximum number of carbon in the chain. Now what the chain means is the branching is here. You can see a branching here, right? So I'll start the counting from one end. I can, right from here I'll start. If I count it like 1, 2, 3, 4 and 5, I can say see that this chain has 5 carbons, right? So this is my chain number 1. I'm kind of showing you how to count the chains. Okay, now this is my second chain. If I start from here, I have 1. This is my second, let me change the color. This is my second chain. So my second chain has 4 carbons. Okay, and it looks something like this. And similarly, the third chain will also have 4 carbons, 1, 2, 3 and 4. And on this side, it's looking something like this. So I have observed 3 chains. Which one do you think has the most number of carbons?
Ma'am, the horizontal one.
The first one, right? The one with the 5
Yes.
carbons. So I'm going to erase this and just keep the 5 here. Yeah. So very good. Did you feel that it was confusing or it's fine?
No, it's not confusing. It's fine.
Okay. So the longest chain has 5 carbons,
I
right?
got.
And what, yeah, do you see any double bond or a triple bond?
No, ma'am. Only single bond.
Yeah. So I can say that this is an alkane. And what will be the name of this alkane?
Pentane.
Yes, pentane, right. But I won't call it pentane. Why? Because there's one more carbon, right? We can't just ignore this carbon. It's still there in the chain, right? So what we're going to do is this is how many like if I want to satisfy the valency, if then how many hydrogens will I attach to this carbon? It's already bonded on one side. How many valencies are remaining? How many bonds can I make?
Three bonds are remaining.
3. So can I write it as CH3?
Yes, ma'am.
I can, right? So now I just told you what is the name for CH3.
Methyl.
Let's, yes, methyl. So we have I'll call this methyl. So that means in my carbon chain, I have one more compound, you can say, and it's methyl. So what I have to include this in the carbon chain, this methyl. So what I'm going to do is I will count the number till methyl. So 1, 2, and 3. So on the third carbon, I have my methyl. Okay. So now look I am going to write it. I'll take 3 dash methyl, 3 methyl pentane. Okay. 3 methyl pentane. Why? Because on my third carbon, I have got a methyl group and the whole chain is pentane. So if someone says that, did I get stuck? Should I repeat?
No, ma'am.
Okay, yeah. So if someone tells you that Fatima, draw this, draw the structure for this or draw the compound, like how will this look, then you'll be easily able to draw it. How first you'll see the parent carbon chain, like the bigger chain, it's pentane. So you will draw 1, 2, 3, 4, and 5. Now they are saying that on the third position you've got methyl. So you'll count from any side, like 1, 2, 3. This is my third carbon from this side also, and 1, 2, 3, third carbon from this side also. And on this, I will add my CH3. Clear?
Yes, ma'am.
Should
So
I repeat? Is there
basically,
any?
no, no, ma'am. Like, if there is three methyl maintained, like it means like third carbon, we have to draw that methyl, right?
Yes. Yeah. Basically, what this nomenclature is trying to do is it will like give you the whole address, like of any particular hydrocarbon. So if they're saying 3 methyl, that means you will see a methyl on the third carbon of the pentane chain. So they are breaking it down for you, so it's pretty easy. If they'll tell you like draw this, so it's easy to draw it, and even to name the structure, so it's pretty easy. So this is clear. Shall I move on to another example?
Yes,
Okay.
yes,
Now, so we in the last class we drew butane. Butane. Okay, butene. Let's take butene. Hmm. Yeah. So butane means I have four double bond because there is an ene, and because of
yes.
butane I have 1, 2, 3, and 4 carbons, right?
Four
Now
carbon.
to satisfy the valency, this is CH3, CH2. This is again 1, 2, 3. So just CH.
Two.
Okay. And this is 1, 2, 3. So 4. Clear? I've
Yes.
just drawn butene. Yeah. Now, this is simple butene. If they ask you to draw butene or identify butene, you'll be able to do it. Now, if instead of making a double bond here, I would have made it somewhere like, let's say this was C, C, C. So 4 carbons. If I wanted to draw it here, like CH3, 1, 2, 3, 4. 1, 2, 3. Am I audible? I think. Oh yeah. Yeah.
Yes.
Okay. So this is 3. The valency is correct here. So 1 here, 2 here, and 3. Yeah. So the valencies are correct. Now, do you think this is also butene?
No,
No, right? Now, why do you think it's not butene?
ma'am, because there is not CH3. There is no CH2.
No. See, why it's not butene is because like uh the position of the bond has changed, right? First in the first, see this CH3 and this hydrogen, it depends on like the bonds of the carbon. So it will change. Okay, so you like how will you identify it? Basis on the bond, on the basis of the bond. So in this, the bond was here and like it shifted to this position, right?
Yes, ma'am.
So now we have to basically use the nomenclature. We have to name this new whatever we have got this compound. So I'll start counting. Now again, one more thing. So we prioritize important things, like we have got a few tasks, but we like do it by prioritizing them. The one which is more important, we'll do that first. So similarly, we will prioritize double bonds. Okay, so let's say this, let's look at this chain only. So I will not start from counting here. I will not start my counting from here, 1 2 3 4 4, like the double bond is at third position. No, I will start from here, so that my double bond receives the lowest position, like the smallest. So 2, my double bond here is at 2. So I'll choose this chain where my double bond is like at the small, where I can like have the double bond earlier. Now, this is my this is what we have to name. So because there are 4 carbons, I'll start from any of the sides. The number will be same. Let's see, 1 2 3 and 4. 1 2 3 and 4. So the like double bond is between 2 and 3 only, right? So what I'm going to do is, this is butene, sorry. The double bond is with at which number?
Second.
Sorry.
The second one, ma'am.
Yeah.
CH.
Yes, at second. So the double bond is at second. So what I'm going to do is, I'll write it as but, but to okay. It's a butane. On the second carbon, we have got a double bond. Ene means double bond. Second is the position, and but is the number of carbons, which is 4. Easy. It's a little different, but to ene, but because we don't have any functional group or anything, we'll call it but to ene.
Ma'am, then can't we call pentane methyl 3 as pentane 3 methyl?
Pentane, no. I'll come to that also. There is a reason why. Now, let's solve a few more, then you'll get your answer. Now, so for we have, so the rules, we know that we have got 2 rules. First, the longest carbon chain, right? We are count
Yes, ma'am.
first. We'll prefer the we'll count the number of carbons, and the one with the longest chain, that is what we'll prefer. Then we'll prioritize double bonds, triple bonds, and functional groups. Now, with that, let's take an example of a functional group also. Let's say I have got C, like 6 carbons, and I've got a functional group at here. So this is chlorine. So I'll call it chloro. Okay. And let's count the number of carbons. It's a straight chain, so we don't need to count them like the biggest chain, because it's a straight chain. And how many carbons can I see? 1 2 3 4 5 6. So there are 6 carbons. That means it is penthex. All right. So do you think it's an alkane? Do you see any double bond or triple bond?
Ma'am, it is hexane.
Hexane only. Yeah. So hexane. Now we still have chlorine. So I'll name it the exactly like how I'll name it the same way I did with methyl. Okay. So it at which position is chlorine?
Third.
Third, right? So 3, instead of writing chlorine, we in the previous class we did
Chloro.
the functional group table. So what will I write?
Chloro.
Yes, very good. So chloro. So 3 chloro. Third position we have 3 chloro, and the whole chain
Hexane.
is 3 chlorohexane. Clear? Easy.
Ma'am, what if we count from the left side?
From this side,
Yes.
1 2 okay, 1 2 3 4 5 6. Now, remember I said prioritize double bond, triple bonds, and functional group. Now, chlorine is a
Hmm.
functional group. So, this example I gave you, that we will try to reach the double bond as quickly in the smallest amount of carbons we can. So in this we didn't choose the third one, right? We'll consider this. We'll start from this so that the smallest position can be given to the double bond. Similarly, if I started from the other position, the left side, then my chlorine would have been on the fourth position, 4 chlorohexane, right? But I need to prioritize my this functional group. That's why I've started from this side, so that it's on the third position. Okay,
Like we
clear?
need to get the smallest number for it.
Yes. Yeah. 4 chlorohexane, uh, we will not write, we'll write 3 chlorohexane. Okay, we need to have, yeah, we'll get the smallest number. Now, you were saying this question, you had this question, why methyl first and why pentane afterwards. Now I'll write down something. It might be a little confusing at first, but you'll get the point of what I'm trying to write. So, whenever there is a nomenclature, when you have to name something, this whole thing, this is what how you will like go through. So first you'll write the position of substituted carbon. Now, what is this? The methyl, ethyl. Okay, so am I audible?
Yes, ma'am.
Okay, yeah. So substituted carbons are these extra carbons that are like from this chain, that are the substituted carbons. Okay, so they can be methyl, ethyl, propyl, any carbon. So first you'll uh find the position, write the position for them. So this is the position of substituted carbon. Example, what are the substituted carbon basically? Ethyl, methyl. I've given you a few examples. Now after that, write the name of the subs write the name of the substituted carbon. Okay, I'll explain this also. Name of substituted carbon. Now this ethyl and methyl, it will be written here. And in the position, now let's go back to this example. In this, what is the position of methyl? Am I audible?
Yes, ma'am, you're audible.
Yeah. So what is the position of methyl in this?
Third.
Yeah, third. So when I say position of the substituted carbon, that means the number. So in this case, in our case, it was third, like in the example we did. So third, then write the name of the substituted carbon. So that was methyl. This is the order we went with. Position,
Yes.
name. Yeah. Then we need to write the root. We are familiar with what root is, right? In the beginning, when I introduced hexane, heptane, alkane, not alkane, ethyl, methyl, so all the ith, meth, prop, but, yeah. So I wrote the word root here, right? So
Yes.
this all was ith, myth, prop. So this is what I mean here by root. This is what I mean. So word root is basically the alkane, alkene, alkyne, whatever you have. So not alkene, but ith, myth, and so on. Now after this, you have to write the position of double bond, triple bond. Now let's go back to this example where we had a double bond. So but to ene. But is the root. So we wrote the root first. Then the position of double bond was 2. So we wrote 2. Now after that, we will write ene or ine. Okay. or even ane.
In. Yes.
Hmm. Right now it's like looking a lot, but once you start solving like while by looking at this table, then you'll be able to understand. Now, position of functional group, then we'll write the position of functional group. Like in this, the functional group was 3.
Yes.
The position of functional group, and then the suffix of functional group. So the suffix of functional, I'm gonna write just FC is the functional group. Okay. So we will like use this kind of, you can say table or you can say order to write down the nomenclature. Okay. Now, till here, is it easy for you to understand or is it getting confusing?
It's easy, mom, but like I don't
Mhm.
understand like why like three is first and then chloro is second, hexane is third, like that, like the order.
Okay. One more thing. See, this you have to write it like this because why? Because this 4-chloro is on what? Like, if this 4-chloro is on hexane, right? Chloro on fourth position is at like on which thing is it? So it's on hexane. So,
Yes.
so that's why we're sorry one. All right. Let's continue. Yeah. So what I was saying is this 3-chloro. This chlorine on third position in is on which thing? So it's on hexane. So that's why we are doing that. So like we'll start from the smallest and smallest and then we'll go to the bigger things. Right. So the whole thing, like whatever comes before is on which is on what chain or what thing? It's on hexane. So that's why we're writing it like that. Right. So similarly, 3-methyl pentane. So methyl is on third position. I know that, but uh, like किसकी third position पे है वो? तो pentane. So it's on the third position of pentane. Okay.
Okay, ma'am.
Okay. Now, this was so the doubt is clear.
Yes, ma'am.
All right. Now let's solve a few questions.
So,
Right.
ma'am, basically, first we will write on which like first, second, third, which number carbon is it? Like if it's in third, fourth, and then we'll write the functional group, chloro, fluoro, like that, and
Mhm.
then third we will write the whole group. Like if it's six carbon, then six hexanal, like that, hexane.
Yeah. Yes.
Okay.
Yes. Now, prior, let's say we have got a carbon chain. Okay, let's take it one by one. There are a lot of rules. Like at first, when I have to tell you, like there are a lot of rules, but once you like start solving it, then all the rules like get like fit into your mind. Now, let's say I've got 3 carbons, or let's say 4 carbons. Now I have chlorine on 2 carbons, right? So how will I write this? First, let's use this table only. Okay. Do you see any substituted carbon?
Yes.
Okay, where?
First and last.
No, no, no. These are chlorine. Are you talking about these?
Yes.
These are chlorine. Substituted carbons are ethyl, methyl, CH3, C2H5. So yeah. So if there
No.
was if there was a carbon here, then this would have been a substituted carbon. Okay. But there's no
Oh,
substituted carbon in this chain. Okay.
okay, ma'am.
Clear? Yeah.
Yes,
So
ma'am.
we will skip this one because there is no subposition. That means there is no substituted carbon also. Right. Now let's name. Let's check out the this. How many carbons do you see?
4 carbon.
4. So what will be the word root for this?
2 chlorobutane.
No, just the word root, butane, right? We're taking one step by step. So butane. So I know that it's butane. But I'll write it like a little afterward because like this whole thing is on which thing. So it's on butane. So butane will be written at the end. Now position of double or single bond. So only this table we are able to, this part we are able to use till now. Do we have a double or single bond? Sorry, double or triple bond?
No, ma'am. Only
So
single
I'll
bond.
Yeah, so I'll remove this also, and because I don't have anything from here, I'm using ane. So I already wrote butane. So word root was but, and from this I wrote ane. Now, what do we have any functional groups?
Yes, ma'am.
Okay, and where do we have the functional groups?
First bond and last bond.
First and last. So this is 1, 2, 3, 4. So the position for functional group is 1 and 4. And what is the suffix for this functional group? Or even
Chloro.
suffix slash prefix? Chloro. Yeah. So chloro. Now one more thing. Now we have two chlorines. How will I write that? I will write it like 1, comma 4. That means on both 1 and 4, I have chlorine. Okay. 1, 4, dichloro. Di means 2. Can you see two chlorines?
Yes, ma'am.
So dichlorobutane. 1,4 dash dichlorobutane. So I have dichloro means two chloros. First chlorine is at first position, second chlorine is at fourth position. Di means two chlorines at on a butane chain. Okay,
Yes, ma'am.
should I repeat?
No, ma'am.
Okay, so 1,4 dichlorobutane. All right. Now let's say I have, instead of this, I have 5 carbons. I have a chlorine here, and here I have got bromine. Okay. Now can you so first, what are we going to look?
Ma'am, you made
Is
butane.
there any substituted carbon? Yeah. Oh, okay. 1, 2, 3, 4, 5. Yeah. So how many carbons can you see?
5 carbon.
5. So it will be pentane. So I'm going to write pentane. No double bonds, so pentane. Now, how many, like, can you see?
Ma'am, your voice is breaking.
Okay, am I audible now?
Yes, ma'am.
Yeah, okay. So how many functional groups can you see?
Functional group.
Two functional groups, yeah. It's okay. So the functional group is kind of
Ma'am, is it 2 comma 3 chlorobromopentane?
you can say it's halogens, but like yeah, you can see. Now wait, a lit you're lit am I audible or am I getting
Ma'am,
stuck?
your voice is still breaking.
Okay, am I audible now?
Yes, ma'am. Now you're audible.
Okay, so how I will write this is okay. So you said 3 chlorobromopentane. Okay. Now 2, 3. I will write it like 2 comma 3 chlorobromo only when I have the same thing. Okay. Like two, if I have two chlorines, then only I'll put the because there are chlorine and bromine are both different. So how I will write it is, first name it 1, 2, 3, 4, 5. So I know that at second position I have chlorine, third position I have bromine. Now the thing is, which one should I write first? Should I write chlorine first? Should I write bromine first? Now if you like, according to you, I think you thought because chlorine is coming first, then you should write chlorine first. Okay, but there's one more
Yes.
rule: alphabetical order. You have to follow alphabetical order because B comes before C, like in alphabetical order. B is before C, so you will write bromo first. Okay, the position will not change. The longest carbon, everything rule is same, just you have to write it like differently. So I have bromine at 3, so I will write 3 dash bromo, 3 dash bromo, comma 3 dash bromo, comma 2 chloro. Just give me 1 second. Yeah, no, we are, yeah, no, why did I put the comma? Okay, so 3 bromo, 3 dash bromo, again a dash, 2 chloro, 2 chloro, and there's no other functional group, 5 carbons, so pentane. Okay, 3 bromo, 2 chloro, pentane. Done? Easy.
Yes, ma'am.
Now,
Ma'am,
mhm.
won't we write like 3 bromo then comma 2 chloro?
No, no, no. Comma will be there when you have like two of the same things and you're writing them together. So when then only you'll put the comma. Okay.
Okay.
Did I get stuck? Should I repeat?
No, no, ma'am, you'll not get
Okay.
stuck.
Okay. And the same thing, I'll add it here only instead of making another chain. If I had 3 chlorine, so it would have been whatever. Let's say I had one position at 3, 1, 2, 5. Now because I have 3 chlorine, so for 3 I will write trichloro. Let's say I had it on pentane, so trichloropentane. Okay. So if I
Yes,
have
ma'am.
2, then dichloro, 3, then trichloro, single chlorine, then just 1 chloro or whatever position chloro. Okay. Similarly for any like functional group, even methyl, so 2, 3 dimethyl, 5, 7 dimethyl, like that. Okay. Now,
Yes.
one more example, then we'll move on to the next topic. Okay. So
Yes.
this is my functional group C double bond C. CH3, CH3. Hmm. Now, can you tell me where will be the longest carbon chain? Where is the longest carbon chain? Um, let's do it together. Oh, it's your first time trying, so just whatever you think, just tell me whatever you think
Ma'am,
will
the
be right.
middle one?
Okay, so I want the longest carbon chain, right? So if I start from here, like 1, 2, so I can either go to here, here, or here. So it will be 3, like any one of would be like 3, 3, and 3. But to make it even longer, can you see like it like this, right? Can you see this chain?
Yes, ma'am.
Wait, yeah. So that's the, so this is the 4, we have got 4 carbons, right? By any other way, we're getting 3 carbons. But if we look at this chain like this, then we are getting 4 carbons. Okay. Now let's try solving it. Let me write the number of carbons also. Okay. So I'll start from here. 1, 2, 3, and 4. Okay, 1, 2, 3, and 4. Now, where now 4 means how many chain is like how many, what is the root for this?
Bute.
Yeah, bute. And the double bond. Remember, we made one bute.
Butene.
So how will I write this? Just bute. Like how will I write butane in the form of like when I have double bond? We just did one example. Don't add any functional groups. Just tell me in terms of beauty.
Ma'am,
Um,
bute, and then a number, and then ene.
yes. And at what number is the double bond forming?
2.
Yeah, 2. If it was at 3, so it would have formed here, but it's at 2. Okay. So bute 2 ene. So I know that like this everything is forming on bute 2 ene. Now can you now these four are in the carbon chain, but this and this, these are not in the carbon chain, right? So that means they are the substituted carbon, right? And what is the name for this CH3?
Methyl.
Methyl, yeah. And at what positions are CH3 and CH3?
1 and 4.
1 and 4. 1 and 4 or 2 or 3? See, at 2, it's substituted at 2, and the other is substituted at 3. Okay. So when I
Um,
say the position, you have to tell the number.
I thought you were taking the slanting.
Sorry.
I thought you were taking that chain from that chain you were asking.
Okay, like the bigger one that I made.
Yes, ma'am.
Then still it would have been this only. This would have been 1, 2, 3, 4. So you were saying at okay 2 and 3. Still it would have been 2 and 3 only. Let's
Oh,
take it the way.
oh.
So one, yeah, okay. So we have two methyls and one is at third position and is at second position. So I'll write it like in number forms, like increasing numbers. So 2 comma 3. I have two methyls. So should I write dimethyl, trimethyl, or just methyl?
Dimethyl.
Yeah. 2,3 dimethyl butene is the name for this compound. Okay.
Yes, ma'am.
Sorry, were you saying something? I think your voice was breaking.
Ma'am, can you just like explain from the structure, like this big name, like how did we get?
Okay. What is wrong with my screen? Just give me 1 second. There's something.
Oh,
My OneNote is not responding, so I'll have to sharing and do it again. Just give me 1 second. Give me a few minutes, cause oh yeah, let me share it again. The screen. Hmm. Can you see the screen?
yes, ma'am.
Okay, so this structure was given to us in the question only. Okay, so let uh, C double bond C, and they made four CH3s here. CH3, 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 and CH3. Now we have to find the like longest carbon chain. I have to include both the double bonds. So I could either start from here 1, 2, and make it like 3. But this would have been 3 carbons. We need to have the biggest carbon chain possible, longest carbon chain possible. So instead of doing that, I decided to start from here. So 1, 2, 3, and 4. So as a result, this is the longest chain that I got. Okay. Did I get stuck?
No, ma'am.
Okay. So this is the longest carbon chain. So 1, 2, 3, and 4. Now, these are the substituted carbons, right? Because they don't have any position in the carbon chain. So that means they're the substituted carbons. Now the substituted carbons are what? 1 carbon and 3 CH3 is methyl. I can see that there are 2 methyls at 2 positions. One methyl is attached to the second carbon, right? And the other methyl is attached to the third carbon. So I will write it like 2 comma 3 dash methyl. This is now I have, so this is I've named the functional group substituted carbons. Now we have to name the main chain. I can see that there are 4 carbons, so it's going to be a butane. The root is going to be but, and there is a double bond at 2. So it's going to be but 2-ene. So 2, 3 dimethyl actually. I didn't add the di because there are 2 methyls. 2, 3 dimethyl but 2-ene. Clear? Do you still have a doubt?
It's clear, ma'am, but like, why are we taking 2, comma 3? Why aren't we taking 1, comma 4?
Because this is the first carbon, right? Is there anything attached to this carbon?
No, ma'am.
Any no, this is the 4, 1, comma 4. We're not taking this because it's a part of the chain, right? We are counting 4 carbons, butane. So these are a part of the chain. Now, substituted carbons are those which are not a part of this chain. So in this case, these are not a part of the chain. So that's why we are taking 2 and 3. And this will not, and this 2 and 3 will depend on the number to which this is attached. Okay, so let's solve it like in another way. Let's say this was again the same thing, but let's count it like differently, I think, because that might solve your doubt. So CH3 and CH3. Now the thing is, instead of starting from here, like 1, 2, 3, I'm going to start from here. Same thing, 1, 2, 3, and 4. Now again, the first methyl is at second carbon. Wait, this is a part of the functional group, sorry. Now yeah, so this all, let me highlight the chain. So this is my carbon chain, right? Now
Yes,
at
ma'am.
what position is the substituted carbon attached to? Is there anything attached, any substitute attached to this first carbon?
No, ma'am.
No. Second carbon, anything other than the chain is there present on the second carbon?
Yes.
Yes. There's a methyl
Methyl.
group present here. And the third, yeah, and the third one, is there
Right.
anything present here?
Yes, ma'am. Methyl.
Again, methyl. So my position 2 and third carbon. So 2 dimethyl, sorry, I keep on writing methyl because we have 2 methyls.
Dimethyl.
Yeah, 2 comma 3 dimethyl but double bond on second carbon. So but to ene. So I hope that cleared your doubt.
Yes, ma'am.
Yeah. Okay. Now let's move. So this was all about nomenclature. I'll give you a few questions in a minute. Let's solve out the time. Yeah. Now let's move to a new thing called homologous series. All right. Now this homologous series, no, before that, we have to focus on the formula, like how this chain increases. So you have like till now, like you are very clear with the concepts of alkane, alkene, and alkyne, right? So
Yes.
now alkene is when this carbon single bond, alkane double bond, and alkene triple bond. Now we have, so they have like a particular order of increasing, right? They increase in a particular order. Like if it's a like this carbon is always increasing with like 1 plus 1 plus 1 plus 1. So in alkane it's C, sorry, in ethane, methane it's C. Then in ethane it's two carbons. In it with prop there are three carbons in propane, four carbons. So it is increasing by the number of one, right? Now this will be the same for every like every chain of the carbon, whether it's double bonded or triple bonded or single bonded. So C and N is basically here. Let me write down. N will be equal to 1, 2, and we'll start from 1 and it will keep on going as long as you want. Okay. So if I talk about alkane, so in this case, C, if C is 1, okay, let me add some space and we'll solve a few questions. It's pretty easy. You just have to remember what formula each one has, and then you'll be able to like tell whether the particular thing is alkane, alkene, or what. Wait, where did it go? Yeah, here. So let's say I have C3H6. All right. So I know that this C3, so whatever number with carbon is, so here carbon with carbon, the number is 3. That means my N will be equal to 3. Okay. So now I have got this formula for alkane CnH2n plus 2. Now, listen carefully. It's not that difficult, but N is how much?
3.
3. So I'll put C3. H then 2, and there is 2n plus 2. So N is how much again? 3
3.
plus 2. So 2 threes are 6. 6 plus 2 is 8, right? So that means C3H8. Sorry, am I audible?
Yes, ma'am.
Okay. C3H8. Now, but the formula they gave us was C3H6, and our final answer is C3H8, right? So that means that, and the formula we used was from alkanes, right? Alkane, I used this formula from alkanes. So this proves when this is not equal, like it's not equal to C3H6, this proves that this is not an alkane. Okay.
Mm, yes, ma'am.
Okay. So this is not an alkane because the formula is not like fitting, you can say, not an alkane. Now let's put another formula, right? Let's try it with the next formula because we have one for each. Now, for alkene, we have CnH2n. So if we have C as 3, N as 3, this was for alkane. Now we're doing for alkene. The formula is Cn and H2n. So our N was 3. So C3 H2 into 3. 2n, right? So 2 into 3.
Yes, ma'am.
So how much will it be?
C3 H.
C3H6. And they gave us in the question that C3H6, right?
Yes, ma'am.
Right?
It's equal.
Yeah. So that means this is an alkene. Okay. Alkene with 3 carbons. And what is the alkene with 3 carbons?
Propane.
Propene. Propene. Propane is with single bond, right? Propene is with double.
Yes, ma'am.
Yeah.
Propene.
And if this was still not equal, then we would have applied this formula as well to check it. Okay, now can you tell me whether this is alkane C5H8? Can you solve this and tell me whether it's an alkane, alkene, or alkyne?
Okay. Ma'am, N is the number of carbon, right?
Yes. Yeah, N is the number of carbon.
Ma'am, it's an alkene.
It's an alkene.
Yes, ma'am.
Okay, let me check. Alkene means that if it's 5, then it should be double, right? Alkene with double bond, this is what you're talking about.
Yes, ma'am.
Okay, so for C5, it should be 2 into 5. So it's not alkene because it should have been C5H10. Alkene,
Ma'am,
you can learn it like, see, if C is something and the double H hydrogen should be the double the carbon. Hydrogen should be the double of the carbon. So whenever you'll see the double of the carbon, like in this case, C3H6, then it will be an alkene. Okay?
ma'am, the formula that you wrote below CnH2n, the CnH2n minus 2, that I followed.
Okay, okay. Use these formulas, this one. Alkane, use these. Try again.
I used
Try.
all the below formulas.
Okay, okay, okay. Those are for rings. Okay. These are for,
Okay.
remember when we studied structural isomer, uh, there was a difference in the number of hydrogen in both rings and that. So that's why they have different formula. Use the branch one.
Okay. Ma'am, alkyne.
So it should be, if it's alkyne, then it should be C is 5, so it should be 10 minus 2, 8. Yes, very good. So it's an alkyne. Now I've got a few more questions for you to solve. I'm gonna hide the answer. Just give me 1 second, I'm sharing a picture. Alright, so can you see the picture?
Yes, ma'am.
Okay. Now, from this, let me tell you which one you should solve. Let me also mark this. Solve this one, C7H12. So tell me the answer for C7H16, C7H16, C7H12, and tell me for C9H20 also. Okay, just three. Then we'll end the class.
Okay.
Apart from this, if I ask you to draw like 2,3 dimethyl or 2,3 dimethyl butane, like if I ask you to draw those, will you be able to draw them?
Maybe.
Okay. I'll give you that in assignment. Try solving that. And if you're not able to solve them, I'll tell you how to make them in the next class. When you have solved even one of them, just tell me the answer. Okay.
Ma'am, first one is alkane.
The one with which one are you talking about? C7H12 or C9H20?
C9H20.
Is alkane? Yeah, it is alkane.
Ma'am, second one is also alkane. Ma'am, third one is also alkane. Alkyne.
Did you get it as alkyne or did you got alkane?
Calculation mistake.
Okay. But did you get the right answer now or should I explain?
I'll do it again.
Okay.
Ma'am, I got right answer.
All right. So that's all for today's class. We did the one more. Yeah. Okay. So we'll start with homologous series in the next class and the properties or chemical properties of hydrocarbon. Okay. Now the syllabus will there's less explanation because in these topics need a lot of explanation. Like the whole nomenclature took one class, but now we'll complete more topics in like a single class. Okay, and you'll get the notes after the class. Thank you for joining. Do you have any doubts?